This is the final video for Chapter 4 on graphs and transformations, and in this video we're just going to very quickly discuss what happens when we sketch reciprocals and how we can transform reciprocals. If you remember, reciprocals have asymptotes. Asymptotes are lines that the graph comes very close to, but the graph actually never touches. And you can see on the diagram that we've got the graph of f of x equals 1 over x minus 2 plus 1. And you can see that graph has a vertical and a horizontal asymptote. The vertical asymptote is at x equals 2. And the reason is that x equals 2, if I substituted x equals 2 into the function, you can see that I would get 1 over 0, which is undefined. Therefore, x can't equal 2. And therefore, we need to put a vertical asymptote at x equals 2. We've also got a horizontal asymptote at y equals 1, and that's because when we are transforming the graph, the plus 1 at the end has pushed what was the horizontal asymptote, which was the x-axis, up to 1, so we get y equals 1. We can also find out where this graph crosses the x and y-axis. We'll look first of all for the y-intercept. That's when x equals 0. And of course, if you put x equals 0 into the function, you get y equals a half. That's why there's a half marked on the sketch. And if you set y equal to 0, remember, which is the same as f of x, and you solve it, you'll get that x equals 1. So that's what my basic graph looks like. So when we transform a reciprocal graph, we also transform the asymptotes if they need to be transformed. So if something's happening in the x direction, the vertical asymptote will change, but the horizontal won't. And if something happens in the y direction, the horizontal will change, but the vertical won't. So let's have a look at some of these. So the first one, we want 2f of x, which is a stretch of scale factor 2 in the y direction. So the first thing that will happen is, notice we are still going to have a vertical asymptote at 2, because vertically nothing's happening, it's horizontally. Okay, we will have a horizontal asymptote at 2, because the horizontal asymptote at 1 stretched to become a horizontal asymptote at 2. The coordinate 0, a half will become 0, 1. Okay, and the root at 1 will not change. 1, 0 will stay as 1, 0, because it's only the y that changes. And of course, if you multiply 0 by 2, you still get 0. So the graph, when I draw it, looks something like this. So again, like this, it goes through at 1, it goes through here at 1 and down. Okay, now again, we want the original, the new equation. Now we know that f of x was 1 over x minus 2 plus 1. That was the original. Okay, that's plus 1. If I multiply the whole of that by 2, the new equation, right, the new equation, I'm going to write it as y equals, that will be 2 over x minus 2 plus 2. So I've multiplied the whole of the original function by 2. And the next one, again, think about the transformation, f of x minus 1. That means we are going to translate the whole graph minus 1 in the y direction. So because we're looking in the y direction, anything in the x, in other words the vertical asymptote, will still be at 2. But this time the horizontal asymptote that was at 1 is now going to drop onto the x-axis. And I'm just going to mark it so you can see it will drop onto the x-axis. Okay. I'm now going to draw it, and then I'll put in a few key things. So the whole graph has dropped down by 1, so this is what's happened. And where the graph intersected at a half on the y-axis, it's now going to intersect at minus a half, because it's come down by 1. And again, if you look, the original graph, I'll write it again here, was f of x equals 1 over x minus 2 plus 1. You can see what we're doing is we're taking 1, so this will be y equals 1 over x minus 2 graph. Look at the third graph. Third graph is f of x plus 3. So that is a translation of minus 3 in the x direction. So everything will come back 3. So the vertical asymptote that we had at 2 now becomes a vertical asymptote at -1. The horizontal asymptote doesn't change. That's at 1. Okay. And then we can draw our graph. Yeah, draw it like that. And this one comes down like that. Okay. If we find the equation, okay, remember what this is telling us to do. It's telling us to replace x by x plus 3. So the original f of x was 1 over x minus 2 plus 1. So the new graph, and I'll write f of x plus 3 equals 1 over x plus 3 minus 2 plus 1. Therefore, y equals 1 over x plus 1 plus 1. And using that, you could work out that this graph actually crosses here at 2 and here at 2. And again, the final one that we're going to look at is f of minus x or negative x, which is a reflection in the y-axis. Look at the original, we had a vertical asymptote at 2. We reflect in the y-axis. That will become a vertical asymptote at -2. Our horizontal asymptote is still at 1. And then we just need to reflect the whole thing in the y-axis, so that will come down like this. This one will come down like this. Can you see? And again, let's work out what the equation is. If we remember, that tells us to replace x by -x. The original, of course, I'll write it again, is 1 over x minus 2 plus 1. So we are replacing x by -x. We're going to get y equals 1 over -x -2 plus 1. And if you use basic algebra, you can work out that it's actually x -1 and this is a half. Okay, but again, you can see that from the reflection. And that is the last video for chapter 4.